Hi everyone, in this video we're going to go through the fifth module of Datacamp's free Introduction to R course, Data Frames. Okay, in this module, we're going to talk a little bit about the use of data frames. So in particular, why we would use a data frame, what a data frame structure is. We're going to talk a little bit about data sets and how to create a data set in a data frame structure. It's going to give us a working example about planets and the size of their rings and how to subset some of that information within a data frame. And then lastly, we're going to talk a little bit about sorting with a data frame. Okay, so what is a data frame? If any of you are familiar with dataset structures, maybe some of you have worked with SAS or SPSS or other types of software, maybe Excel, where you work with various rows and columns of data. A data frame really is a two-dimensional structure of arrays or vectors where we can use multiple types of data, such as logicals, numeric, and characters. So they've loaded for us a data frame and it's called mtcars. So what we could do is take a look at mtcars. I'm just going to highlight here and then run the code. We could take a look at the code. So in this particular data set, we have different types of cars for the observations, and we have different types of variables that describe those cars. So when we first get a data set, we're interested in exploring the type of data that we have. And there are various functions that we can use to do that. So here we have the head function and the tail function. So what we can do is call the head function and pass through it our data frame, which is mtcars. We'll run the code, and we'll see here that we get the first 6 observations of the data frame mtcars. So we get the first 6 cars along with all of the variables that describe those particular observations. Similarly, we can do tail. So we'll do the tail function and we'll pass through mtcars. We'll run the code. And then that'll give us the last 6 observations of the data frame. So that's one way when we first receive a data set and we want to explore and investigate what the data set entails, we can use the head and we can use the tail functions. Another function that we can use is the stir function or the structure function. And the structure function is going to give us a little bit more of a broad analysis of the type of data that we have in the data frame. So it's going to give us the number of observations, the number of variables, a full list of the variable names, the data type for each variable, and then the first observations of the data frame. So what we can do here is we can use the structure function and we'll call in mtcars. We'll run the code. And we can see here that it's going to give us all of that information, and here's how we see it. So we can tell here that the data that we have is a data frame. It has 32 observations and it has 11 variables. It has listed each of the variables, the type of data that we find in the variables, and then the first few observations for each of those variables. So now creating a data frame. We can either import data from a data set that we might have, or we can build a data frame within R itself by building vectors. And so here what they've done is that they've built multiple vectors, and what they're asking us to do is concatenate these vectors into a data frame. So you see here that we have multiple vectors. We have a name vector, type, diameter, rotation, and rings. And so what it's asking us to do is that we want to create a data frame from these vectors, and we want to name it planets_df. So you can see here that we're going to name the data frame planets_df. We're going to use the data frame function, and we're going to pass through the data frame function each of the names of the vectors. And run the code. Okay, now that we've created the data frame, it makes sense to check the data frame to make sure that everything has been passed through correctly. So here it's telling us that we should have 8 observations and 5 variables. So what we can do is we can use the stir function, and we can pass through with the new data frame that we just built, planets_df. We can run the code. And of course, the structure is telling us that we're correct. So we have 8 observations and 5 variables, name, type, diameter, rotation, and rings, with a call out of the first few observations. So similarly to vectors and matrices, we can also subset information from a data frame using the bracket syntax. So as an example, we have my_df 1, 2 selects the value at the first row and the second column. Similarly, we can use a colon if we're interested in selecting a range of rows or a range of columns, or if we're interested in selecting all of the rows or all of the columns. It follows the same syntax structure as previous modules have talked about with calling out all of the rows or all of the columns. So it's telling us here that we have the previous data frame that was built, planetsDF, already stored, and we can check that by using the ls function. And it's telling us here that we have the data frame, and we can explore the data frame by calling it out. And it's showing us here that we have the 8 observations and the 5 variables. So what it's asking us to do is subset part of the data frame. It wants us to print out the diameter of Mercury, which is row 1 in column 3. So we can use the planets DF data frame, and we can use the brackets to subset, and it's telling us specifically we want row 1 in column 3. So we'll use 1, 3. And we'll run this. And it's telling us here that the diameter of Mercury is 0.382. Now it's telling us here that it wants to print out data from Mars, which is the entire 4th row. So we can use the planets_DF data frame. We use the brackets to subset. And if we want the entire 4th row, we'll just use 4 and then a comma. Let's run the code and submit the answer. So in the same fashion that we did with matrices, we don't have to use the column number to do subsets. We can actually subset by calling in the name of the variable. So in this particular example that they give us, rather than using the number 2, we can use the variable name type instead. So the instructions here, they want us to select and print out the first 5 values in the diameter column of planetsDF. So what we can do here is use the planetsDF data frame. We can subset, and it wants us to use the first 5 values, so 1 through 5. Of the diameter column. We'll run the code, and there are the first 5 values. Okay, so here it's giving us a little shortcut in what we can do to call out a particular variable from a data frame. So previously we used the column number and we used the column name, but we can also use the $sign notation to call it out as a shortcut. So the instructions here is that it's asking us to select the rings variable from the data frame, and we want to store it in a new vector and call the new vector rings_vector. So it starts out by telling us that planetsDF is preloaded into the workspace, so we can check once again by using the ls function. And let's explore the data frame one more time. So using the new notation, we can use the planetsDF data frame, we can use the $sign, and then it's asking us to call in the rings variable. And we notice here that we've assigned it to a new vector entitled rings vector. So let's run that. And then it wants us to print out the rings vector. And it's giving us the information for the rings vector. So you probably remember from high school that some planets in our solar system have rings and others do not. Unfortunately, you cannot recall their names. Could R help us out? So if we type rings vector in the console, we'll get all of the information for all of the rings. So let's do that. Rings vector. So here's all the information of whether or not a planet contains rings. We have instances of false and we have instances of true. And we notice that the first 4 observations are false and the last 4 observations are true. Now our objective here is that we want to get the information for the planets that do have rings. So for the last 4 observations, we want to get all of the information for those planets. So the code that they've given us here are all of the names of the planets of the rings vector. And what they're asking us to do is that we want to see all of the planet information. So in order to do that, they're asking us basically just to get rid of this name and to leave it blank. So we'll run the code. And we have all of the information for the rings that are true. So we'll click Submit Answer. So rather than subsetting the way we just did, an easier and more efficient way to do that is to use the subset function to call in whatever information we're interested in. And so with the subset function, we have 2 arguments that we want to pass. The first argument is the data frame that we're working in, and then the second argument is the subset condition, which will yield some sort of condition. And so what we did previously, it makes more substantive sense for us to use the subset function. So what we could have done instead is we could have used the subset function. We could have passed through the first argument, which is the planet's data. And then we could have said subset is equal to rings. We'll run the code, And we'll notice here that we get the observations just that are true for rings, so the planets that do have rings. So let's delete this. And what it's asking us to do is to use the subset function on planets to select planets that have a diameter smaller than Earth. Because the diameter variable is a relative measure of the planet's diameter, your condition is diameter is less than 1. So we'll use the subset function to do that. We'll pass through the planet's data. And then subset is equal to diameter less than 1. Run the code. And you'll notice here that we have planets with a diameter less than Earth: Mercury, Venus, and Mars. So we'll click Submit. So a lot of the times when we're working with the data frame, we'd be interested in sorting the data either alphabetically or numerically. So in order to do this in the context of a data frame, we can use the order function. So in this particular example, what they've done is that they've created a variable, they've named it A, and they've concatenated 3 numbers, 100, 10, and 1000. And what they're asking us to do is they want us to sort those in numerical order from least to greatest. And so the instructions here are just to play around with the order function in the console. Let's just replicate what they've done here. So we're going to create a variable and we're going to name it A, and we're going to concatenate 3 elements: 100, 10, and 1000. And then what it's asking us to do is order that. So we can use order function, and then we can call in the variable. And so let's run the code and get the values. So we'll see it says 2, 1, and 3. And so that might not be the answer you thought you would get. You probably thought you would have seen 10, 100, and 1000. But what it's actually doing is that it's defining the ranked position within that vector. So you notice that 100 is the second largest digit, so it's giving us a value of 2. The second element is 10, which is the smallest, and it's giving us a value of 1. And 1000 is the third ranked, so it's giving us a number 3. So what if we just sorted A? We'll use the sort function, and then we'll run the code. You probably thought you were going to see 10, 100, and 1000. Now, the sort function is good if we're working with one vector or one variable and we want to sort those particular digits. But what you have to remember is that we're working within the context of a data frame now. And so if we use the sort function, all that's going to do is take that one vector or that one variable within the data frame, and it's going to sort that, and it's going to misplace it with everything else. So if you have one variable that's aligned with multiple observations, it's just going to change the order of that one variable, and so everything's going to become mismatched. And so when we're working with the data frames, we have to use the order function to do that. And so what we've done here is that we've used the order function on A, and it's given us the ranked positions, 2, 1, and 3. And so what we can do is we could take that output now, and then we can order it using the syntax that they've provided here. So to alleviate any confusion, let's just get rid of this sort for a second. So we can use the vector A, and then we can use the subset function, and we can use order on A. And then now if we run this code, it's going to give us the values of 10, 100, and 1000. So keeping in mind, we get the same result, but when we're using it in the context of a data frame, using that ladder syntax is going to allow us to change the order while keeping everything else combined with it. So that way we don't have just one variable that's mismatched according to everything else. So I'm going to submit the answer here, and we'll move on. And so here it's giving us an example of how we can sort our data frame. So we have the planet's data here. Let's just double check, and let's take a look at the planet's information so we can refresh our memory of what we're working with. So what it's asking us to do here is that it wants us to call the order function on the planet's data, and it wants us to sort by position. And once we sort by position, it wants us to create a new variable called positions. And it's giving us the $ syntax to do that. So we can use the order function, and we can call in the planet's data. And specifically, it wants us to order by diameter. So we'll run the code. And then we'll call in the new variable that we just built. And so here we have the same information that we saw before. It's given us the positions of the rankings within the variable itself. And so now what we can do is we can take the data and we can sort it by positions. We'll run the code. And the error is because I used planets and not the actual name of the data frame. Okay, so let's run the code. And what we have now is the data frame that's been rearranged and sorted by position. Okay, in the next video, we're going to talk about using lists. I hope you enjoyed the video and found it helpful. If you did, make sure to give us a big thumbs up and like the video. If you haven't done so already, be sure to subscribe to our channel by clicking the link above, and make sure to check out some of our other videos. We'll see you again soon.